Welcome all, good evening all, and I'm glad to be here with you all. So today we would look more into product development. We're going to, as mentioned earlier, we're going to go through the process of how you move from a prototype down to an MVP. We're also going to, while doing that, look at things to avoid and the right or the best way to go about your product development. So I think for us to even move, we'll have to even know what exactly product development is. So by normal definition, product development is a process of improving a product to meet customers' requirements. So it's as the name goes, a development process where you start up iterating your product till it meets what the customers want. So we'll look at why does this product development, why does it matter? Why do you need to go through the product development stage? So the first thing we talk about is that we know that every successful product always starts with an idea. Think of any products that, whether software or hardware, every product starts as an idea. So the inventor had it as an idea, and then it's now grew into a product. So as long as for you to have a product, you have to start through an idea, you must go through a product development stage. Now, we also know that the structured development reduces risk and improves outcomes. So with respect to going through the product development stage, you are able to have structure in your product development. Think of it as if you are trying to cook, right? You want to make rice or jollof rice. If you don't have a specific process of cooking that food, which most people call a recipe, right? If there is no structure to you cooking that food, it's as good as a disaster. Basically, you would cook a disaster. So, and if you are going the professional way of having a restaurant and you don't have recipes on cooking, it means that that restaurant will not work. So, if you are to compare it to making a product or having a product, you must go through a product development stage. That product development stages are what gives you structure, and having that structure reduces risk and improves your outcome. Also, we would look at we know that understanding the stages also helps you to build faster. As I mentioned earlier, if you have a recipe, you might end up not being able to cook your food or even bake your cake faster if you're going into baking. So with having a structure, when it comes to developing your product, it helps you to build your product faster and in a smarter way. So for us to, now we know that, okay, we need product development because it gives uh, our product, or should I say, it makes our process of making our product to be more structured. We would look into the 5 major phases that are involved or you have to go through when it comes to developing your product. The first phase, which is what everybody goes through at the onset, is ideation and conceptualization. So at this stage, this is where you form the idea of at least having a total, or should I say a rough sketch of what your product should look like or what you want to achieve. Example is you are always hot and then you're like, oh, I need to make a product that can generate air and cool the temperature or cool the environment or reduce the environment. Maybe your room is always hot. So, or should I say people are having issues of high temperature. So in your head, the idea is that, oh, I need to build something that would reduce the temperature or make the temperature go down to room temperature. that's a rough idea. So you have that idea. Then the next thing is you start having conceptualizing it, which is okay, since I know this thing, okay, is supposed to reduce the temperature in the room to room temperature. Okay, I think I need to have a concept of how this should work. Should it have, should it look like a fan? Should it just have blades? Or should I go the route of a refrigeration, which is like, should it be an AC kind of system? So these two goes hand in hand, ideation and conceptualization. So you have an idea. The next thing is you start creating concepts. So your concepts are usually just rough sketch. So you can have a rough sketch on a piece of paper, which might be a sketch to show how the system looks like, or even a sketch that that is in a form of a diagram that shows every module, or should I say blocks of what you need to achieve to, or should I say how the product should look like or how it should function. So ideation, conceptualization are usually the first stage. When you are done with that, that is when you start going into prototyping. Now, in the prototyping phase, you've understood your idea, you've understood the concepts. The concept is the approach that you want to use to solve a specific problem, or should I say, create your product, which definitely is solving a specific problem. So in the prototyping stage, you have various stages in prototyping. The first stage in your prototyping is what you call a POC, that is a proof of concept. Now, the POC is usually a very rough prototype, low fidelity prototype, as we call it. So usually has the most basic function, or not just basic, the most critical function of your solution should be on your POC. So this, as I mentioned earlier about the reducing the temperature of a room. So if you are going the fan way, your POC can just be a basic blade and a motor just to test your concepts to see, okay, would it even drop the temperature by some degrees? That's what you go via a POC. Then when you have confirmed your POC, um, then you now move to the next stage of having a high fidelity prototype. Now, again, the idea of POC, of creating a prototype, is to help you to go to the next stage, which is validation. Now, when you have your prototype, that is when you can now validate your idea to see, okay, will this idea work? Now, if the idea does not work the way you've conceptualized it, that means you have to go back to the stage one, which is you have to either change your idea or change the concepts in which you are trying to solve a specific problem. And then you go back, prototype, and then validate and test. Now, when you are done with your validation and testing and you are okay with that, the next stage is for you to start building an MVP, which is your minimum viable product. Now, after the MVP, which is the first product that can go out into the field for your first customers to use, to test and run a pilot test per se. Then after that, definitely during the period of testing of your MVP or usage of your MVP, you get to the last stage, which is the market feedback and iteration. So the feedback you get from the markets is what would help you to now make iterations, because definitely from your own end, you might have said, okay, this is the idea, this is how it should look like, and oh, it works, it solves this particular problem. But when it goes to the market, that is where you start seeing all manners of problems will start coming out. And that is where you have your feedback, and then you start making iterations. Those iterations might be big iterations that might take you back to your ideation or conceptualization stage, or it will just it will just be a very minimal iteration that you are going to be doing in that. So this in a whole is just like a rough sketch. So we'll just start going through all of them and see what is involved in each of them again. So in ideation and conceptualization, as I mentioned earlier, what you do more is you identify problems that are worth solving, and then you also define your target markets. So for you not to be able to, or should I say, for you not to be going back and forth with respect to the phases that are in your product development, in your ideation and conceptualization stage, you should be able to identify if the problem you are trying to solve is worth solving. I think this is one of the major fall, or should I, drawbacks in a lot of, for a lot of people that are, developers, innovators in Nigeria. A lot of us, follow buzzwords to create products, and we don't do a bit of market validation to confirm that, oh, this, if this idea is viable, if it is worth solving, like this particular problem. Yes, there's a lot of problems, but most problems are not worth solving, probably but because the market doesn't care about the problem. That it's a problem, but they might not be willing to buy a solution for that problem, or the problem in itself might not be, or should I say, that's much of a pain point for the target market that you're looking at. Which is the second thing here, which is you have to define who your target market is. Who are you targeting this product for? Imagine building a solution, a luxury product, right? It might be, just think of any luxury products, right? Now, when you hear luxury, you know that luxury is not for the very over under average Nigerians, and then you build it and you are targeting people living in Ajegunle, not to but you get what I mean by Ajegunle. Looking at people in Ajegunle to start using your luxury products, they might not be able to afford it, right? Or you are looking at people in very remote areas using a luxury product, not even about even affording it. They might not even need it at all. They might not see the need for using that luxury product. So, as I said, you have to look at your targets markets first while you are doing your ideation and conceptualization. Now, again, you have to make early sketches. So while you are ideating, you must have sketches. I mentioned this earlier. You should have sketches. Your sketches might be either on paper or a drawing board. It might be a diagram. It might be a graph. It might be on a CAD software. So it depends, but you should have your early concepts being sketched out. And again, market research, definitely you must do a market research. So all of these go hand in hand during that your conceptualization and ideation phase. You must follow this. And when all of this is followed through, the result is that you would have a product that fits the problem. So it's like a problem solution fits, right? So you have a product that can fit the problem, and should I say that can fit the solution, of a particular problem you are looking at. So, and also you definitely would also have a bit of wish list when you are doing your conceptualization. This wish list might be extras that you want to put into your product, but at the end of the day, if you go through these processes, you would have less issues moving your product to the market, especially because what's the foundation of your product is the ideation and conceptualization phase. It's just like a house. If you have a bad foundation, you would keep patching and patching, and at the end of the year, you have to tear the house down. So this is a very important phase when it comes to product development. Then we look at the prototyping phase. As I gave a bit of a rundown on all of this, the prototyping stage, as I said, is for you to be able to explore the feasibility of your products. Will this product work when it is deployed in the market? Is it a product that's, even if as the technology works and all, is the markets, would it really suit the market that I'm pushing it into? As I mentioned earlier, the first thing you do is you do a POC, which is a low fidelity version of the prototype that you are looking at building. So it's usually either a mock-up or paper model, or just if it's an electronics project or product, you can just, before going to a PCB design, you can do your design on a breadboard, which is a very low fidelity, just to test out your idea. And the second thing you pay attention to is you must focus on key functionalities, right? So in the prototypes are not supposed to look beautiful and appealing. They're not supposed to look posh. They are usually very rugged, not aesthetically pleasing. But the idea of prototype is for you to be able to test out key functionalities of your product. It doesn't make sense for you to focus on aesthetics in while developing your prototypes, forgetting that the reason why you are doing this prototype is for you to be able to ascertain some key functionalities of your product. The key functionality, as I mentioned way earlier, is looking at maybe building a fan solution, right? And for a fan, the key functionality is that the fan should be able to deliver enough breeze, right, when it is working. And if you are looking at, oh, I need the fan to be aesthetically pleasing, but at the end of the day, the blades are not able to give enough thrust to push out enough breeze, it will be a failed prototype, or should I say a failed project if it looks you're focusing more on aesthetics at the onset. So you should focus on functionality, on the key functionalities of your product, and not looking at it being posh. So yeah, so for your mock-ups, you can so the softwares you can use, or things you can use for your mock-up, if you are doing like a software solution, it could be either Figma or InVision. If you are doing a hardware prototype, the best platforms to use, you can use the Arduino, you can use the Raspberry Pi. So these are like platforms that you can use for fast prototyping before you start going deep into maybe writing your codes in assembly language, or just going, deep OEM kind of programming. You can first test out your prototype using these platforms. So at the end of the day, the outcome that you are expected to have if you follow this kind of procedures is that you would have a working model that demonstrates core functionalities. And basically that's what you need to be looking at your prototype stage, being able to ascertain that the core functionalities that you set out to solve at the onset of your ideation are being achieved at the end of your prototyping stage. So the next stage is for you to now validate, since, okay, you have your prototype now, so you have to go through the validation and the testing stage. Now, why are you trying to go through this stage? Is to be able to prove that your solution works and it matters. So the validation is for you to see, okay, this product works. It's there. You're testing it. It's working. The people that are, maybe you are doing a pilot test, they are giving you, good feedback. So at the end of the day, you're trying to get feedbacks. You're trying to also conduct usability tests, because the truth is, the way you use a product is not the way a person would use it. Hence why you find out that most products, someone might use that exact product for 10 years, another person will use it for 2 months and it gets spoiled. So different people have different ways that they operate, or they will be operating your product. So it means during this period of validation, you are trying to see how your users would be using this product. Are they using it well? Is it easy for them to use? Are they breaking it while they are using it? And these are everything. All of this is what you get from the feedback, during your validation and testing phase. And this enables you to, to make iterations to your product. And then one of the key questions that you ask yourself at the end of this particular phase is, You ask yourself if the product solves the user's problem, and are people also willing to pay for it? Because I think the second one is the most, should I say, is the major question you also ask yourself after you've, okay, you see solving people's problem, beautiful, but do people have willingness to purchase it? Because the truth is, if people are not willing to purchase your solution, it would be a beautiful decoration in your hand. People would like, oh, they like the idea, they like that it solves their problems, but they'll be like, man, Oga, it's too expensive. So these are things you also consider, or you ask your questions you ask yourself when you are going through this validation and testing phase, because this would help you make iterations. Probably the functionalities that you put during your prototyping stage are a bit, many of them might not be needed. And the more functionalities you put in a product, the more expensive it becomes if you are looking at it at hardware products. Maybe a bit of software products also have that too. But once you are increasing functionalities in a product, the price increases. And you also ask yourself, these functionalities, do my users, do they need it during your validation and testing? Do they need it? Is it something that they want? And if they need it, and or even if they don't need it, but they are willing to pay, then you move on. Most times, if they are not willing to pay and they don't need some functionalities, you can remove those functionalities, and then it will definitely reduce the price of your product at the end of the day. So we look at the MVP. So what is an MVP? So the MVP is known as minimum viable product. Now, this can be said to be a simplified functional version of your product. So it's once you're done with your product design, your prototyping, you're done with your validation and your testing, the next thing that you go into is to now develop the first, should I say, the first products that will be sold to, or should I say, pushed out to the market. So this is your minimum viable product. So it's the simplified functional version of your products that has less features, just only has the essential features for you to test this market fit, to be sure that, okay, this product fits in the market. I think many of us must have, with time seen that you buy a product today, and next year they launch version 2, the upper year, or maybe even that year before it ends, they launch another version, another variant of the product. So this is basically the process. So at your initial stage, you would definitely have an MVP, the first prototype. Now in that prototype, you don't want anything to go wrong. So it means you only put essential features in your products. Very essential features. Let me go back to the fan example. You just probably want to just have an on and off switch, right, in your fan. Maybe moving forward, or even maybe on and off switch, and then have like a toggle switch to change the speed. Moving forward, you can now say, okay, I want to put a soft touch switch. Then another MVP variant or version, you say, okay, I want to make it to be controlled with a remote. Then another one, you might say, okay, I want to make it to be IoT based. I want to be able to, control it from my phone through the internet anywhere I am. Another variant, you might say, okay, I want to add a bit of AI to the fan, so that it will be able to be monitoring the temperature, regulating it, know when I'm around, and So you see, it's iterations that you have to do when it comes to MVP. But the first MVP for that product has to be very, very, would I say basic? Like it has to just have the most essential features for that product, because this is the product that you need to use to enter the market. At least you need to have your customers you need to gain confidence from your customers, because you don't want to have too many features and then a lot of bugs in your product, and then it's people will be like, it's a flop, and they wouldn't be able to jump into getting your product. So as I said earlier, when we look at ask ourselves a question, which is why MVP first. So the reason is that you want to save time and costs. The idea of the MVP is that so you can easily enter the market and then learn from the market. And you want to reduce the risk of building the wrong products, and also be able to enable data-driven decisions. So you just want to first do a minimum viable product before you dive deep and give your all into the product and start adding functionalities. You just want to do the simplified functional version of your product. So let's look at some tips when it comes for building MVP. As I said, we mentioned in the earlier slide about it being simplified. When you are developing MVP, you should always have this particular, you should use the Moscow method. Now, what is the Moscow method? Now, the Moscow method tells you of the things you must have, the things you should have, the things you could have, and the things you won't have in your MVP. So as it goes, must have, should have, could have, won't have. So the first thing you consider is the things you must have. You also consider things you should have. And then you consider less things you could have. And then things you won't have. Those ones are things that should never come into your MVP. You should also keep your MVP, keep it lean. That is, do not over-engineer. I think over-engineering is also one of the issues that most, or should I say, I've seen in the past with a lot of inventors or people that want to, go through their product development journey. A lot of people, you have so many ideas of things you wish your product or you feel your product can do. Because of that, you want to pile every functionality in one product. The truth is that when you do that, you make your product to be too complex, you over-engineer it. At the end of the day, you would have many failure points. So the more complexities you give to your project, or should I say to your product, the more failure points you would have when the product goes out there in the field. In the lab, it might perform very well, but when it goes out in the field, you will start seeing that you might not even know how to solve most of the, because complaints will be coming on a steady of, oh, this one is no longer working, this function is no longer working. So that hence why you should always keep it very lean and avoid over engineering. You can also use open source tools. I think I mentioned that way earlier when it comes to prototyping, your prototyping phase. You go open source tools because with open source tools, you can quickly build your MVP products. Then when you are satisfied, you can now start saying, okay, I want to build a closed loop software. You want to start, developing like an OEM. But for your early stage, it's best to just use open source or off-the-shelf components. And yes, you should always plan for scalability later. You don't plan for scalability at the onset. You plan it later. During your MVP stage, you just want to quickly learn and know, okay, if I should continue with this particular product or if I should just drop it or if I should do more iterations on it. But when you start planning for scalability during that your MVP stage, it's not the best way to go about it because it means that you would incur more cost building your MVP if you are planning for scalability at that early stage. So yeah, once your MVP is in the market, the things you need to do when it's in the market, you should be able to collect data. So this is usage metrics and user feedback. So these are things you must collect when your MVP is out there in the market. If you don't focus on collecting this data at that point. You might not be able to get your feedback on time. You might not be able to do iterations. You might not be able to see if your product has a market fit at the onset. So you must, find ways, or you should plan for things like this. You should plan for collection of data collection once your MVP is out there in the markets. You should be able to validate assumptions from your original idea. So you should be able to, because definitely when you are building your product, there's a lot of assumptions that you have with respect to how the product should serve, people. Once it's getting into hands of users, you have a whole lot of assumptions. So you should be able to validate those assumptions when the product hits the market. In fact, this is basically what I do majorly all the time. When I build a product and it's out there in the markets, I start validating. Then I start, validating all the whole assumptions I have. In fact, I asked my customers, I asked them questions. I ask them questions. Have you tried using it in this way? What did you notice? What did you notice? So you validate those assumptions and to know if they work or if those assumptions were actually wrong. And yes, lastly, you should be ready to pivot, iterate, or double down. So when your product is out there, and you are collecting information, feedback from users, you should always be ready to iterate and pivot. So this is not the time for you to start making arguments with your users and telling them, no, it should be. So you should be someone that is, should I say, someone that is ready to listen to your users and know, okay, this is the complaints I'm getting. Okay, I think I should iterate in this manner. Or I think I should, because the truth is, when you are building product, you are building it to satisfy the consumers. If your product does not satisfy your consumers, it would find it difficult breaking into the market or being successful. So these are tools and frameworks that you can use. I mentioned this earlier. So these are a couple of tools and frameworks that you can use when you are trying to, go through from your prototype to an MVP. So there are a couple of free tools out there. Some are paid, but most of them are basically free tools. So if you are looking at wireframing and design, Figma, Sketch, Adobe XD, during development, GitHub, Flutter, React, and Node.js. If you are for hardware prototyping, you can do for their firmwares, do Arduino. The Arduino framework is open source and it is very popular when it comes to fast prototyping. Hardware, you can use ESP32, especially if you are building a product that requires Bluetooth, Wi-Fi, etc. For PCB prototyping, there are a couple of platforms or softwares that you can use that are free. KiCad is there. What they call it, Altium, although that one is a paid software. You have Proteus and Eagle, etc. So there's a lot of platforms out there you can use. So when you are collecting your feedback too, so I think I use Google Forms. It's very easy and it's free. So you can always use Google Forms to collect feedbacks. You can draft a feedback, which should I say, you can draft a form which you send to users, and then they can give you, feedback on all those checks that you need to check when the product is out there with your users. So the common pitfalls to avoid. So I think we mentioned a couple of them earlier, but iterate. So over-engineering. So at your early stage, you should avoid over-engineering. You should always keep it very lean and simple, very simplified. So for you, when you're building MVPs, be it a software or hardware product, do not over-engineer. Secondly, as I mentioned, not so long ago. You do not ignore real user feedbacks. You don't ignore feedbacks from your users. When they are giving feedbacks, you always listen and find a way to satisfy your customers. So make iterations, keep making iterations until at least you've met. Because if you're having feedback from, maybe you have 100 users, 1,000 users, and then the feedback you're having from at least half of them is in relation to a specific part of your solution, or should I say a specific problem that they are encountering. When you start ignoring them, even if it's 10% of your users, you don't ignore, their feedback. And again, you try as much as possible not to fall in love with your prototype. I think this is what many of us do most of the times. We start having this thing called tunnel vision, whereby we focus on the prototype, focus on a specific way or a specific prototype, do or die. This prototype must work, or should I say, this project must work. The truth is that not every idea is viable. If you have done a bit of iteration and then you see that it is not viable, maybe you should change your approach, or you should change the idea as a whole. Or maybe the problem you are trying to solve is not worth solving. So try as much as possible not to fall in love with your prototype so that you don't, you know, get stuck in a tunnel vision trying to uh, push it down people's throat when it's very clear from all the signs that this project or this product is not, is not, the market is not ready for it yet. So also do not skip validation. I mentioned this a couple of times. Validation is one of the basic things you do, especially if you've gone to an MVP stage. Um, you must validate, you have to make validations. This would enable you to be able to iterate and also know the trajectory which your product is going towards, if it's going to be a success or not. The last one is I think this is one of the things again I do see many people fall trap for, when especially when they are over engineering. So a lot of people, when they are developing products, they over engineer with an idea that they want to serve everybody. You cannot build a product trying to serve everybody. You must have a target audience, or should I say target market. So you should build for a niche market, right? A specific people. Now, for my products, GreenJolt, when I was developing it and all, I wasn't focusing on the market of people who are looking to power up their full house, power up their refrigerators, their air conditioner. The market is there. If someone wants a solution, a solar solution for something of that nature, they can easily go to the market and buy inverters and all the exist. But I was looking at the niche market of people who are not able to even afford the smallest inverter solutions, people who also want something that is compact, people who are remote workers, people in the markets, even household who just want something that will solve their need and not their wants. What is their need? In the market, their need is just to power up their fan, turn on the light in their shop, and then probably charge their phones. For remote workers, their need is they want to power up their standing fan, their laptop, their router, and charge their phone, basically, you see. And, this is the niche market I was looking at. So this is the what you look at. You develop or you design your product to serve a niche market, not to serve everyone. Because when you start looking at serving everyone, that is when you start over engineering, and then you might end up losing the whole market. So in conclusion, I believe we've been able to learn a couple of things, which is when you are going through your product development journey, you should always start very lean, don't over-engineer, do the most basic functionality in your MVP. You should also be able to learn fast, which is when you collect feedback and during your validation, collect feedback, you should be able to learn fast and iterate fast. You get so be able to iterate often as soon as you are getting the the validations or the feedback from your users. Iterate as fast as possible. Iterate more often. That's where you'll be able to make your product be better. Because without iterations, your product cannot get better. The other thing is that your prototype is the first guess. So when you are developing your products at the prototype stage, that is like the first guess to okay, how your solution should work. So the prototype gives you a guess to okay, this is how it should work. Because remember, when you do prototyping, you validate. So that's your guess. The validation will tell you if it works or not, the validation and testing phase. Then if it doesn't work, you go back. So basically, we know that the prototyping stage, or should I say, your prototype is your first guess, whereas your MVP is your first test. So in the MVP stage, that is when you first test it in the market. So to know if it would work or not. Um, Another thing is we learned that we should focus on solving a real problem with the least amount of effort to learn the most. So I think that is very self-explanatory. So as I said earlier, a couple of people they are trying to solve a problem that is not so, I wouldn't say, yeah, not so real, a problem which is not worth solving at the moment, and then while they are trying to solve it, they put the highest amount of effort in solving it. They over-engineer, and I don't think that's the best way of going through um, a product development. You have to start very small, learn very fast, iterate very fast. That's where you are able to get to a product that has a problem solution fit. If not, it will be very difficult for you to break into the market easily. It will be difficult for your product to be a successful one. I think at this stage we would be rounding up, and at this stage we would, I think this is the stage where we can discuss on your ideas, your challenges, and then next steps. So yeah, so whoever has any question, this I think this is the best stage we can now discuss on all of this that we have learned so far. Thank
Thank
you.
you so much, Engineer Josiah. That was a wonderful one. Please let's
Thank you.
give him a digital applause. Digital applause. Thank you so much, Engineer Josiah. I want to first appreciate my immediate past national chairman, Engineer Kautume. I think she has dropped, she's no more on the call. Yeah, but she was with us shortly. That was well appreciated. I want to just read what she said at the comment section. It says she appreciates our presenter whose mastery of the subject has kept us engaged. And she has gone out now for another meeting. But I'm going to, support what she has said. It shows your mastery of the subject, and it's coming from a practitioner. You're a practitioner in the space, building your product from a prototype to the MVP. I think the first time we met at that Raspberry event, it was your products were one of the, products that were displayed, for us to
Thank you.
see a working product in the market, already doing something. So you're not just talking as somebody who is theoretical, you're talking practical in practical terms. I have a lot to say, but I would like to open the floor to others But while opening the floor to others, I was expecting for you to show us your products and maybe the different
Okay.
stages, of the development of your products. From that one, you said you should sketch it first. Maybe looking at it from your sketch or your book, and for it,
Yes.
maybe one on software where you're able to do one that was looking one kind of way. But
Yeah.
wait, still
Abs-
getting
I-
better and better till. So I'm hoping to see that, and I think that
oh,
alone too, can spike something or spark something the hearts of
yes.
some people here. Because I can see some young people, in our midst, that
Mm.
this knowledge, they can take it from here and also be able to do something spectacular, just like you're doing in the consumer.
Yeah, I wish I could have shared it. I just had a bit, should I say,
Or
the
just you can
little.
even share
I
the
just didn't
latest
want to
one.
over-engineer the whole
No, no, no.
the
That's
whole
that's the core.
presentation.
That's the core. That's the core.
Um,
Let's see it's real. Show us what you've done. With
okay. So
this knowledge.
I could. Oh, okay. Maybe I could just show one of it here.
Yes.
So this is one of the
Can you
products.
imagine? This is a Nigerian product, too, not
So
yes.
yeah, so this is one of it. So this
Yes.
one is like my camera is not focusing. Sorry. Maybe let me remove the blur. Okay. I I believe we can all see it.
Yes, we can.
Exactly. So this is just a portable power solution. So this is one of it.
Designed and manufactured by you, by your company.
Yes,
Yes.
exactly.
So that's a
So
good
yeah,
thing.
it's I would have I would have loved to share the
Yes.
iterations because I had a lot of iterations before getting to this stage. And the truth is that when you get to an MVP stage, you still have a lot of iterations that is still going on. So
Yes.
versions upon versions to solve. Now you start from what you're hearing from customers, from your users. You can now do iterations for it to be able to fit more people because the truth is a lot of assumptions were made when designing, but when it gets to the market, you see that okay, some people will be like, can it be like that? And then you're hearing it more often from a couple of people. I wish it can do this, I wish it can. And you're like, okay, okay, we can do that. And then you satisfy those customers, giving them those functionalities in a different variant or version. Yeah.
Yeah.
It's a slow process. And it's not a constant process. It's ever changing.
But I can tell you that you're one in a million. I'm not trying to praise you, but these are the steps we need to take as a country. Earlier we were talking about it that when we look at the software industry, we've done very well. But when it comes to hardware development, we're still lacking
Yeah.
behind, and our
Yeah.
prosperity is embedded within the hardware production cycle. Just like every
I
other
agree.
country, like China and every other manufacturing company in
True.
the country in the world.
True.
So before I continue, let me open the floor. Questions, observations, comments for our speaker. I know they got you, but it was well explained. So except they want information based on their work, their practice. So please, the floor is open. If there's anyone who wants to ask any question. Okay, yes, I was expecting you to do that. So I did not the floor. All right, you're welcome. Introduce yourself so they will
Yes,
know
sir.
where you're coming from and why you need this knowledge. All right.
Okay. A graduate of recent graduate of electronics and electrical engineering, Obafemi Awolowo University, and really, more of into programming. I love that so much. Like, I think one of the things we
Great.
just get stuck to as elect students, know you if you are really hardworking, you like programming. So yes, I have questions and just I think two questions, but I hope it relates well with what we've been discussing. The first question is it ideal and how do you handle a situation whereby you see a market and it's not unique, right? But the solution is there, and then people, there's already a kind of like a company or a particular people providing that kind of service. Like you are coming in as a disruptive how could I put it, a destructive provider now. So how do you also handle that? Is it ideal to actually come into it that way? Like, is there an approach to actually, scale through and, you can actually establish your own brand in that same market? Now, I'm not having a unique idea. And the other question is when it comes to hardware, I was working on I'm currently working on a project, and I needed to use a signal conditioning module. And when I was for three phase particularly, and when I was looking at it, I want to order because I just want to go through an MVP stage, like just get everything done. And I discovered like the kind of signal conditioning this thing I was looking at kind of expensive, and I felt like, so the question is like, how do I even know when, okay, based on the cost I spend on my prototyping now, and it's kind of way expensive, how do I know like if my solution, I know maybe when I started, having a real product, I might scale down, try to find out other alternative to that, building my own circuit from scratch. So, instead of using modules or modules. So how do I know like based on the cost of my prototype, how do I know it's going to fit the market? Like the market will be able to afford it. Like is there some other ways to, go through the research, and I think that's my question.
Okay. So thank you for your questions. They are quite nice. So if I'm looking at the first one you asked about you having an idea and going into the market, and there are already people that are already doing what you want to do. The truth is that every idea that you have, every product, you must have what we call competitors. It's a must. You must have competitors. In fact, it's difficult to have a product and not have competitors. But what you have to do when you are developing your product is you have to know what your unique selling point is. You get what is unique about your product, or what is unique about the way you are solving this particular problem. So every developer or every innovator or someone going through this process of developing their own products must know at the early stage what they are selling, like what is their unique selling point, what is unique about the way they are trying to solve this particular problem. Um, that is why you have, if you are to look at, let's say, cars now, you have variants of cars, Mercedes-Benz, BMW, Hondas, Toyotas. Every particular, these are all competitors to each other. We have Tesla, which is electric. So every one of them have their own unique selling points. They have something that is quite unique about their product. So if you do not know your unique selling proposition, it's difficult for you to be able to disrupt that market. It's even difficult for you to enter the market because people will be like, well, you are doing the same thing. So your USP might be price, it might be functionality, it might be, efficiency. It can be anything you get, but you have to know, you have to, it's a research that you have to do on your own to find out how is my product better than this one's, how how is it better than the one that already exists in the market. So it's a normal thing for you to to face this kind of challenge. In fact, if you don't face this kind of challenge, then you've not even started. It's a must that when you are developing a product, you must have competitors. But it's on you now to do your own research and know, how am I different from these guys? How am I better off than them? Even if they are a company that have been there for years on end, and even if they have billions of dollars in their account based on their revenue generation and what have you, you should also have something that is unique about your own company and why people should go for your company, go for your products rather than to go for their own product. The second question that you asked was around the costs of making a prototype. The truth is that I think I was having that conversation earlier with Engineer Luadara about the cost of hardware. Hardware is expensive. You know, if it was software, maybe not too expensive to develop a prototype or so. The thing is, at the early stage too, while you are trying to go into, as you remembered in the slide, during your ideation and conceptualization stage, you should be able to validate that, is this problem worth solving? Do I have a target user or target market? These things are just things to note, but in practice, you have to go out there and do a market survey. You have to do a market survey and know, okay, is this a real problem? Are they willing to afford this solution if it is priced at XYZ amount price? So you can do that initial, because what you are trying to say is that it's a very expensive endeavor on your own end to start building a prototype when you are not too sure if the market is ready for it or if the market will be able to even afford it. It's on you to go and do a market survey at the early stage, even before you start buying components. You get, but again, you should also understand that while building prototypes, it's very expensive, especially if it's a hardware development. It's usually very expensive and it's a cost you have to bear. Hence why you have to do while you are doing your prototype and doing your validation and going to an MVP, you have to do it as fast as you can so that you'll be able to learn quick and know, okay, is this an endeavor I should keep putting my money into, or I should stop at this early stage and maybe divert my funds or my attention to other products that can be developed rather than this particular one. I don't know if this helps, or do you still have any confusion?
Yeah, it's really awesome. It's really awesome. I think so.
Great, awesome.
Okay.
All
Any
right.
other questions? Observation? Okay, for now, I don't see that. So let me just add a little voice to what you just discussed now from the my student there and for the speaker. You said you asked the question coming into already established market, and I like the way you answered the question. You understand? You just have to know that there are already people there. You have to think about the competitors. But what is unique about yours? You just have to find one thing that is unique about yourself, and you ring that bell everywhere. That's the way to come into the market. You can't say you want to come into to disrupt the market and you don't have something unique that are bringing that possibly will just switch the market in another direction. And at the end of the day, whatever you're doing, it should help the customers. It should be something that will improve the lives of the customers. If you look at what Josiah is doing now, for people that cannot afford the big, the big solutions, renewable energy solutions, and they want something smaller for students. I remember you told me about students, right?
Yeah.
For students and all that, So that will help them. It's cost effective. It's lightweight in quotes. It's movable. It's mobile. That kind of thing, and you can move it around. It has some level of capacity that can charge your laptop. And so it's not just a power bank, it's also in between the big one. And so you just have to have a unique thing, possibly the one you are bringing to the market. I'm just saying now for the student now, sorry, for the graduate now, it's not more a student though. For the graduate now is possibly maybe some analytic tools, and something that will just be different from what's already there, kind of unique. Might not necessarily be different, but something more unique than what is already available. And I want to use this thought of nothing is new under the sun, in quotes. So what we are all doing is innovations. Now, I was speaking to someone yesterday. He's my client, so he was talking about one IT guru that I had known. And in that 20 years ago, this IT guru, offered, was selling software for this international company that has to do with predictive maintenance of equipment or large systems like ships, major equipment. And if you look at the process, you see AI in the process. That's 20 years ago. What they'll do is whatever machine it is, they'll take the manual, they'll open it or pass it through a scanner. The scanner, takes the information, turns it to the ORC thing, readable text. Then from there, extract information about the maintenance, processes of that system. Then it turns it into actionable, points where people can now, when it's time, it will flag it up that, hey, you have to maintain this one. This node that is lost, That's kind of AI, but it's being. So now I was intrigued by that because I was looking at something that will improve that process, which some people are already doing now, digital twin. So adding the digital twin to that kind of process, meaning you have like a model, a 3D model of that equipment now. So not just you're just seeing text and all. So you have a 3D model of that equipment that when you need a maintenance in a particular section of that equipment, it flags it up. You can see it visually, that hey, maybe that place turns red and it starts indicating that you need to change this and that. So I'm just saying that if you want to disrupt the market, like the speaker said, you just have to have your own unique selling point. Then for the prototyping too, see, in practice, prototypes are always far expensive than the mass products. Definitely, because that time you're still bringing things together, you're still buying in few units and all that. By the time you now want to scale up, you still have to do that thing the speaker said, market feasibility, right? To be able to even just do your market survey. By the time it's allowed to have white label, people to do your products at the end of the day. But first, your prototype, you have to spend a lot on it. It's normal. It's normal. It's normal. So I think just to add to what you said, someone has a question here. Philip Adeniji, please. You have the floor. Sorry, please, Mr. Philip Adeniji, engineer Philip Adeniji.
Can't hear you.
Yes, we can hear you now.
We can't hear him. That's what I said.
Oh, okay.
He's muted.
Let me try and unmute him and see. Please unmute yourself. Oh, okay. Maybe there's something wrong with his. Yeah. So
He's unmuted.
Hello, we can't hear you. While he's trying to get himself, let me just iterate, emphasize on some of the points you've given us. One of it again is not to over-engineer. I think that's a problem with many of us, including me. Not to over-engineer, it's just we look at the product and say, is this thing good enough? Is it good enough? And we'll stay in that point for years. Is it good enough? Than to just push it out. And sincerely, I appreciate your presentation. It gives some kind of straight to the point information. Looking at the most cow that you told us now, that must have, should have, could have, won't have.
Have and won't have. Yes.
Yes, those things. And the MVP itself, a simplified functional version, contains only the essential features to test the market. People let's even try that first. But by the time we open our news feed the next day, we'll see one product that's gone far ahead. They say, I'm sure this my product can catch up. See, I wish my product can be like this one. Then you kill that idea, and you don't know that there's a place for pushing that product out like you said, then getting feedback. And I like the feedback mechanism you also showed us. The feedback mechanism, he said, collect usage metrics, user feedback, monitor the churn, retention, and engagement. Of course, you can use AI and all those things now to be able to get. And you said also one-on-one with your customers. And I like that feedback mechanism that you've shown us. Then I think there's one more. Okay, when you mentioned the tools and frameworks, I was expecting in the hardware you mentioned Raspberry Pi, because I think your system is based on Raspberry Pi. Is that Arduino?
So yes, so it's Raspberry Pi. So Raspberry Pi in itself, it's a hardware. So there's a bit of conflict in these things. When you talk Arduino, it's a hardware and also a framework, right? When you look at it from the point of hardware, you talk about their hardware solutions, Arduino Uno, Nano, and what have you, which run on the Arduino framework, right? Now, the framework can support other microcontrollers. It supports the ESP, that is Expressive Microcontroller series. It supports the STM series. It also supports the Raspberry Pi microcontrollers, which are the the Pico and the rest, right? Then we now have also for Raspberry Pi, these are called, the one we know as Raspberry Pi is the MCB. You get, no, sorry, the SBC, sorry, the single board computers. So that is the Raspberry Pi 3, 4, 5, and the rest of them. So that one in itself is a single board computer. If you want a fast prototyping, which you need some things like computer vision and the edge computing, you can do it better on the Raspberry Pi as opposed to using a Jetson Nano to do that. You get, the Jetson Nano is a bit of a stretch because it's not so open source and the community is not so big. But if you want to quickly iterate and have an MVP out there in the market, it's best to use open source platforms to do that. Yes.
And I thank you so much for breaking it down for us, the different tools.
You're welcome.
Yes, that's a good one. So I don't know, now Philip, are you up now?
Yes, thank you very much.
All right, thank you. Welcome.
Am I audible?
Yes, you are.
Yes, we can hear you.
Okay, thank you. Sorry, I was on the road. That's why I had signal issues. Okay. So I actually want to ask a question. It's a little bit downward towards what we're discussing here, but it's in line with what you've been saying. So I noted a lot of things and I really learned a lot. Thank you so much. Yeah, so I'm actually still studying. Yes, I'm presently in school. So I'm in the line of engineering, electronics. I've been pursuing electronics for a long while. So I have my Arduino boards and things like that. Yeah, so I don't know. I'm actually not yet in the market, prototyping. Maybe I'm doing little projects. Yeah, so I don't know what would be your advice for people like us that are just coming up. Still, I'm trying to get little equipment and here and there. So I don't know if you have any advice for us, something that can navigate us faster into building products. Yeah, that's my question.
Okay, so nice one. Thank you so much for your question. So I would say from the point of what would motivate you faster is your final year projects. If I would go that route, for me, when I started working on my final year project was even in my 300 level, 200 level. So that's when I started ideating, you get, and conceptualizing how my final year project was going to look like. I had a lot of options. If it's not the final year project way, you can look at, so the what brings forth products is problems, right? Problems around your surrounding, the ones you can see, the ones you're experiencing, the ones your friends are experiencing, and what have you. I will give you an example of one of the projects. It wasn't really like a product per se. It was like a project I embarked on when I was in school. So I lived in, like, you know how students' lodges look like, and the kitchen was very small, had very small window. So it meant that whenever I'm cooking, my kitchen steams a lot, right? And I was like, okay, how do I remove this steam from the kitchen? The most clever idea I had was putting some sort of extractor in my kitchen to push out air forcefully out of the kitchen, you know. Now, how do I go about this? I went to the markets, found all those AC brushless DC motors that had very high thrust, installed it. But the problem was that the fan was very loud. So whether I'm cooking or I'm not cooking, it's always blowing. And I didn't like the idea of plugging. So the first stage prototype I did was just to plug, and then I used the switch to flicker it off and on. And then I thought about it. I was like, okay, I can actually measure the humidity in the kitchen, the temperature and humidity. So I could put a sensor above my gas cylinder area. So if I'm cooking, the humidity would rise quick. And if the humidity is rising to a specific percentage, I know that, okay, the kitchen is steaming. And then I should be able to turn on the fan. So this was like a concept I had in mind. And I was able to build a small controller system with relays that could switch on and switch off the fan. So when the humidity gets, so I used the DHT11 then, not even a 22. So I was measuring the temperature and humidity, and I was comparing the two of them. If the temperature is going high, turn on the fan, or if the humidity. So why I'm bringing up this real life solution is that there are real life problems around you get that you might be experiencing, whether you directly or indirectly, or your colleagues in school might be experiencing. These are more or less inspirations for you to develop prototypes. You get develop solutions. This is basically the mindset for people like me or like us that are looking at, okay, we want to dive into product development, we want to start making our own product. Whether you want to start selling it immediately or you want to improve upon it for a time before you push it to the market, the whole thing, what springs up products are when you look at real life problems around you, you'll be able to find a solution here or there to be able to, solve that particular problem. So it's not that complex or difficult for you to, just all you need to do is have this mindset of looking out for, discomforts or problems or, around you, and then think of, okay, how can I solve it with this knowledge that I have, when it comes to electronics? What's the simplest? You don't even need to use a microcontroller to solve your problem. It can be just basic analog electronics using diodes, triacs, or MOSFETs or what have you, or transistors. Anyhow, you can always create a logic circuit using these components without even using a microcontroller. And the truth is, microcontroller solutions are a bit more expensive. So someone like you, you might be seeing it as a bit more expensive, but you can really, if you want to really learn electronics, you should first do the analog circuits, using normal capacitors, 555 timers to design circuits which can solve specific problems around you. I hope this helps you.